about the lecture. Do you guys have any questions? Everything's good? So the things that I'm teaching today, mole and converting mole and grams and moles and number of atoms, molecules, and so on and so forth, is really important for the rest of this class. So if you don't learn that, most probably you cannot solve any problems from now on. And most probably you will fail this class. So I emphasize the importance of today's lecture. And for those of you who couldn't attend today's lecture, that's why we have like the online version. So I expect everyone to watch this lecture and reach out to me or your SI pass leaders or your tutors and have everything resolved. And we have one homework and one quiz due the Wednesday after the break. And as you realize by now, I don't provide extensions or makeups for students as long as they have a valid reason. So they were sick for the week, or they had an athletic event that they attended, and they communicate that with me in advance. And if you email me like 1 hour before the homework is due, or like after the homework, I don't provide any makeup. Okay, so plan your time accordingly. And I realized, based on what my SI pass leaders told me, that there are lots of you struggling with ionic and molecular compounds. And I think the main reason is that most of you or some of you cannot distinguish between metals and non-metals. And that is why I have these slides, these 3 periodic tables at the beginning of each lecture to help you know which atoms form cations, which one form anions, and also distinguishing metals and non-metals. That is why I have this table here, and I expect you by now, you can distinguish metals and non-metals. So if you cannot do that, I ask you to go back to the previous lectures, listen to them, read the PowerPoint slides, and if you had still questions, just reach out to me and I explain things to you, okay? Here, different groups and what is the charge of each element if they form an ion, I expect you to know, okay? So if I tell you if oxygen forms an ion, would it be a cation or anion? Anyone? Anion, right? And what would be its charge? -2 or 2-, exactly. So if you cannot write that, we have serious problem in this class, okay? So what about Ca? Would it form cation or anion? Exactly. What would be the charge of Ca? Exactly, right? So make sure to know that for these metals here, I expect you to know for these ones, for aluminum, zinc, silver, we call this N3-, nitride, oxide, sulfide, and then halogens. So these ones you should know by heart. If you don't, just go back to the previous lectures and also study more. So can anyone tell me what is numerical value of Avogadro's number? Exactly, and remember, this number is extremely large. Can you imagine how big this number is? 10 to the power of 22. So in the exam, sometimes I give you which of the following is a numerical value of Avogadro's number, and I say 10 to the power of -23. So something to the power of -23 is extremely small, so it's opposite of what we're studying. So this number is extremely large. And remember, 1 mole is like 1 dozen. It's just like dozen is 12. It can be for anything. So 1 mole of anything is 6.022 multiplied by 10 to the power of 23 of that thing. It can be books, it can be coins, it can be atoms, molecules, ions, compounds, right? Also know that. And I asked you in your quiz and also homework. And sometimes the students think because we're talking chemistry, it should be molecules or it should be atoms. No, it's like dozen. It can be anything. Okay? Any questions so far? Okay, now we want to know, so we said atoms are really small. That's why we don't use dozen. We don't say 12 atoms. We say 1 mole, basically 6.022 multiplied by 10 to the power of 23. Now you may wonder, why that number? Why didn't I say 3 multiplied by 10 to the power of 10, right? So why we specifically said 6.022 multiplied by 10 to the power of 23 of anything is 1 mole, right? So here your book, and I have like the slide exact, as I said, anything that I include here is from your book unless I cite otherwise. So the numerical value of the mole is defined as being equal to the number of atoms in exactly 12 grams of pure carbon-12. So can anyone tell me what is carbon-12? What is this 12? Is it this atomic number? Any ideas? Anyone? Mass, yes. So this is its mass number. Do you remember that we had different isotopes of certain elements? What was an isotope? Anyone?
Different number of neutrons.
Exactly, elements that have the same number of protons, so they are the same element, like chlorine. If I say chlorine 35 and chlorine 37, both of these are chlorine. Both of them, the atomic number is 17. They have 17 protons, but they have different number of neutrons. So they have the same atomic number, but different mass number, right? So when we say carbon-12, it tells you that carbon has different isotopes. But for the definition of mole, we use the one that has the mass number of 12, okay? And if you have 12 grams of carbon-12, right, and then you measure its mass, that mass corresponds to 1 mole. And that's why 1 mole is 6.022 multiplied by 10 to the power of 23, because it corresponds to the number of atoms in exactly 12 grams of carbon-12. And this is something really important that you should remember. And I ask you till the rest of semester, or like I guess in your final and also in your next exam, homework quizzes, that what is the numerical value of mole comes from. And it comes from number of atoms in 12 grams of carbon-12. Does that make sense? Does this sentence make sense to everyone? Any questions? Okay. And now that we defined, yes?
Is it based on carbon-12 no matter what element we're talking about? If that's a carbon.
So that is how, great question. So the question is that, is this based on carbon-12 regardless, or for any element that we're talking about, is this, about carbon-12? And the answer is that, we defined this number 6.022 multiplied by 10 to the power of 23. We defined that based on carbon-12, And after that, we established a relationship between grams and mole and number of atoms or molecules or ions. So after that, we use that for other elements as well. But this is how the definition comes from. Does that make sense? Any questions? Okay. So now, based on this definition, we established a relationship between mass and number of atoms. And this relationship allows us to count atoms by weighing them. And here, we have like some expressions like molecular weight, molecular mass, and we change them. We basically use them interchangeably. So remember at the beginning of the semester, I told you that weight and mass are separate. They are like two different things. But in this context, when we say molecular weight and molecular mass, they are the same thing. So because of that, and because of this definition that we just like emphasized here, we can convert mole to number of atoms, and we can convert mole to gram, and we should write different conversion factors to do that. And this is what we're going to do in this class, to go through multiple examples so I make sure you understand these well. But something that you shouldn't get confused is that 1 mole is 6.022 multiplied by 10 to the power of 23. And if we're talking about 1 mole of atoms, this number would be this many atoms. If we're talking about molecules, this number would be this many molecules. Does that make sense? Okay. And here we have 1 mole of copper atoms. And your book wants to give you an idea, and kind of like, because we have like a number here, and then your book wants to give you an idea of how big this number is, and also kind of like you can give you some tangible examples. Okay, so if you have 1, 2, 3, 4, 5, I guess 1, 2. That's really terrible color choice. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22. If you have 22 copper pennies, that would be approximately 1 mole of copper atoms. Okay? And then here your books give some explanation about like what pennies are made of right now, but that doesn't exactly matter for the purpose of our class. Just remember that 1 mole of copper atoms corresponds to 22 copper pennies. Okay? Now, and I have like the picture from your textbook, and to give you an idea of how big Avogadro numbers is. So we said that 22 copper pennies, they contain 1 mole of copper atoms, okay? But if we have 1 mole of pennies, it means that if we have 6.022 multiplied by 10 to the power of 23 pennies, they can basically cover the entire planet Earth surface. And not only it covers that, it goes to some depth inside too. So basically, 22 copper pennies contain, 1 mole of copper atoms. And if we have 1 mole pennies, would cover Earth's entire surface to a depth of 300 meters. So now your book wants to say how big this number is. Can you imagine that? You have even just pennies. And then if you have 1 mole of that, it just covers the entire Earth's surface. Not only it covers that, it also goes down, So it's just like this number is really, really big. Any questions? Is that clear what we just said? Okay. Now, let's do some examples. So we want to convert between grams and moles of an element. And this thing here, you don't have a multiplication sign here. So when you want to convert mole, and also here. So as we said, 1 mole equals 6.022 multiplied by 10 to the power of 23 atoms. It can also be molecules, it can also be ions, it can also be pennies, it can also be people, right? This is a number, right? And as we said, it's a really, really large number. So if you want to write a conversion factor, do you remember what was a conversion factor? It's the ratio that you write in numerator and denominator, the equivalent of what you have here, right? So you can write 1 mole equals 6.022 multiplied by 10 to the power of 23 atoms, right? Or you can write 6.022 multiplied by 10 to the power of 23 atoms are in 1 mole. And depending on what you want to find, you write the ratio on the left or right. Does that make sense? Any questions so far? Are we good? Okay. Let's solve this example. So it says we want to convert 3.5 moles of helium to a number of helium atoms. Can you tell me what was helium? Was it molecular element, atomic element, molecular compound, or ionic compound? Atomic element, right? All noble gases are atomic elements. That's why we only have like He. We don't write He2, or we don't write HeCl, right? Or like HeCl2. We don't have that. It's just atomic element. So we are given 3.5 mole of helium, and we want to find number of atoms. And as I emphasized before, we're going to use conversion factors from now on. And this is how we solve problems. So what you want to find, you write question mark that thing. So you want to find number of helium atoms, right? So you write question mark number of helium atoms, right? Equals the thing that you are given. What are you given? What are you being given in this problem? What's that? Anyone? Yes? Yes, so we have 3.5 moles of helium, right? So now I want to write a conversion factor to convert mole to number of atoms. Should I write this conversion factor, the blue one, or green one? Which one? So why blue or why green? Yes?
Blue because you want the number, you're looking for the number of atoms. You want that to be in a numerator.
Uh-huh.
Not the denominator.
Exactly. So when you want to write the conversion factor here, you should write it somehow that mole with mole cancels out, right? So if I write it, imagine I write it as the green one, right? I say now how many helium atoms equal, that is not what I intended. Okay, 3.5 mole of He multiplied by, imagine I write the green one, right? So what would be the unit at the end? Can anyone tell me? Exactly. So did this give me number of atoms? No, right? And this is what we call dimensional analysis, using units as a guidance to solve problems, right? So if I just write, these conversion factor on the left, the green one, mole with mole doesn't cancel out. They multiply, and then they become like mole squared. So that's why this is not, you can write that, but it doesn't give you number of atoms. However, if I write here mole of helium, and then if I write this one and I have atoms on numerator, mole with mole cancels out, right? Can anyone tell me what is numerator here? Is it 1? Okay, exactly. So we have 1 mole of anything is 6.022 multiplied by 10 to the power of 23 of that thing. In this case, we have atoms, right? And then when you do this mathematical operation, it would be 3.5 multiplied by 6.022 multiplied by 10 to the power of 23 number of helium atoms, okay? And when we look at your book, let's see, the number would be 2.1 multiplied by 10 to the power of 24 helium atoms. And I always tell my students to check the number yourself after you put that in the calculator. So if this number was like, if this was 3 multiplied by 6 multiplied by 10 to the power of 23, this 3 multiplied by 6 is 18, right? Multiplied by 10 to the power of 23. If this was 4, like 3.5 is between 3 and 4, right? If this was this, it would be 24 multiplied by 10 to the power of 23. And based on writing scientific notation, we know we can write this 1.8 multiplied by 10 to the power of 24. This would be 2.4 multiplied by 10 to the power of 24. So even if you don't have the calculator in the exam, that you should remember to bring, because if you don't, you should solve the problem as I'm solving right now, because I don't have extra calculators to give you. But the answer would be between these two numbers, right? So always check the answer yourself too, so that sometimes students have calculators that they are like more advanced, like TI or algebra or like modern calculators, and sometimes you have like a button for like 10 to the power of something. Sometimes it's different, that you should put 10 manually too. So what I'm saying is that sometimes the students know all the problem, but they put it in the calculator and they put it wrong, and the answer becomes wrong. So if you just check the number yourself, it prevents potential error. Any questions? Is that clear? Okay, if no question, let's now, and here I have the periodic table, and I tell you why I have that moment. And for each element, you read the atomic mass unit, and that number numerically would be the same as molar mass of that element. It means 1 mole of phosphorus has the mass of 30.97 gram. Okay? So remember, this molar mass of copper. Oops. What is molar mass of copper? What is it? Exactly. Gram per mole. So if I tell you molar mass of copper is 63.55 atomic mass unit, AMU, the unit is not correct. The value numerically is the same, but the unit is gram per mole. And this number means that 1 mole of copper has the mass of 63.55. Okay? So I write this here, 1 mole of copper has the mass of 63.55 gram. Okay, what is molar mass of bromine? Can you guys see that well?
79.9.
Is everyone comfortable finding that? So you go to the periodic table. If I give you like bromine or Br, the first thing you do, you go to the periodic table, find the element. And again, you think this is easy, but I have numerous students that they find boron, or they find beryllium, or like barium, or like different elements, not Br. So that's why you should practice to make sure you don't make mistake. Because in the exam, I solve the problem which with all of these elements, write the answer. So you may think you answered the question right while you're not sometimes. So the first thing you do, you find the element. And what is its atomic mass unit? The number below it. Remember, the number above is atomic number, is number of protons. We're interested with atomic mass unit. So this number is 79.90. And what is the unit? Gram per mole. So it means 1 mole of Br has the mass of 79.90 gram. And I will give you this in your homework and quiz. And I say, which of the following statement is not correct? 1 mole of Br atom has the mass of 79.90 AMU. So this sentence would be wrong because the unit is gram. Okay? But if you just say that atomic mass unit of Br is 79.90, that is also atomic mass unit, that sentence is also correct. But 1 mole of Br's mass is 79.90 gram. Okay? Any questions? Okay. Sulfur here, 32.06 entirely. But before I do that, as we said, the definition of mole was based on carbon-12, right? But we can find the mass of all the 1 mole of each element in periodic table. Okay? And the mass of 1 mole of atoms of an element is called molar mass. So molar mass is mass of 1 mole of element. Is there any questions? Okay. So what is the molar mass?
Mass of 1 mole of atoms.
Exactly. Okay. And sometimes when I'm teaching and I ask questions, it seems really easy. But when I check your homework grades, I realize that probably the concepts weren't that easy because the average is low. And especially your homeworks are open book, open notes, open internet, open everything. So when you answer homework questions, check your answers with the slides or internet or resources, right? To make sure you get the points, because homeworks are basically free points because they're open book, open notes, and I asked those from your lecture slides. So molar mass is mass of 1 mole of atoms. And this is really important. We use this till the rest of the semester. That the value of an element's molar mass numerically equals to atomic mass unit. So I repeat that. The value of an element's molar mass in grams per mole is numerically equal to the element's atomic number in atomic mass units. It means that you go to the periodic table, so molar mass unit is gram per mole. Again, is mass of 1 mole of an element. right? But the atomic mass unit has the unit of AMU, atomic mass unit. Does that make sense? So if I ask you, so now here there are like more examples. You have like 1 mole of sulfur, and this number here, again, that is the same. Avogadro number is always the same. 1 mole of anything has 6.022 multiplied by 10 to the power of 23 of that thing. And I keep repeating this number because I expect you to know that for your exam. I'm not giving you the number. So if you don't remember that, you cannot solve the corresponding problem. And also, the way that you find, how can I find this number? 32.06. Exactly. We go to the periodic table that I give you in the exam, and then you read for, you do the same for carbon and lithium. If I ask you that, you go to the periodic table, you read atomic mass unit. And that tells you 1 mole of lithium had that much of grams of lithium. The same thing for carbon. A number of atoms in 1 mole is the same. But the grams would be different for different elements. Any questions? Okay, so now I have some empty slides so I can fill them out with some examples. So first one is your example 6.2. Calculate the number of moles of sulfur in 57.8 grams of sulfur. So this question is reversed. Previously, I gave you number of moles. I asked you the gram. Here, I gave you the gram. I asked number of moles. So what do you want to find? And I just mentioned. Moles of sulfur, right? And what are you given? Gram of sulfur, right? 57.8 gram of S. And anything that you want to find, you write question mark that thing. How many moles of sulfur equals what you are given? 57.8 gram of sulfur. Multiply that by. So now how can I convert gram to mole? Yes? Exactly. So you want gram to cancel out, right? And the only way that it can cancel out is if it's in denominator. And then you have moles on the numerator, and this is the thing that you want to find. And what is this number? We just learned. Yes. So if we had gram per mole, this is the unit of molar mass, right? But here we have the reverse. So this is basically the reverse of molar mass. Does that make sense? And how can I get this number? Anyone?
Sulfur, AMU.
Exactly, we look at the periodic table. And then when you look at the periodic table, you see 32.06. So 1 mole, 32 points. So your book wrote 32.07, and depending on the periodic table that you use, yeah, I mean back of the book is also 0.6, but depending on the reference that you're using, the number can be slightly different, but you don't have to worry about it because I give you the periodic table, and whatever number is listed there, you can just use that. Okay, and now this equals 57.8 divided by 32.06, and this roughly would be 1.80. And what is the unit? What's that? Moles, right? Because grams canceled out. So we have moles of sulfur. So as long as you know how to work with conversion factors, you can convert moles to grams or grams to moles and moles to number of atoms or molecules. Any questions? Okay. Now, let's do another example. How many aluminum atoms are in an aluminum can with a mass of 16.2 grams? Okay, what do you want to find?
Aluminum atoms.
Exactly. You want to find how many number of aluminum atoms or aluminum atoms, however you write it that you're comfortable, equals 16.2 grams of aluminum, right? Now, can I directly convert gram to number of atoms? Can I? How? Yes?
1 mole times 6.022 times 10 to the 23rd. What we did earlier with the mole conversion.
Yes, so we can convert mole and number of atoms, right? But before doing that, we should also convert gram to moles, right? So basically, we should write two conversion factors. Does that make sense? So what we do is that here, you know that you can convert, I told you 1 mole of anything is like 6.022 multiplied by 10 to the power of 23 of that thing. So you can convert numbers to mole, and with molar mass, you can convert moles to grams or grams to moles. So what we do here is that first we convert gram to mole, right? And then we write it gram in the denominator so it cancels out. And we write mole in numerator, and we convert mole to number of aluminum atoms. Can you all look at this and tell me if that makes sense to all of you? So we convert grams to moles, and then moles to number of atoms. Okay? So, can anyone tell me, and we said 1 mole of aluminum has this certain mass. And we find that by looking at the periodic table. And aluminum is group 3A, you read that number, 26.982, right? So you write 1 mole of aluminum, and then your book wrote 26.98, which is consistent with what you have there, right? Basically, you look at the periodic table, you have aluminum, and then the number is listed below. And this number would be molar mass. It tells you 1 mole of aluminum has the mass of 26.98 grams. Okay, any questions so far? Okay. And here you say 1 mole of anything is 6.022 multiplied by 10 to the power of 23 of that thing. So if you know definitions well, I think you can write conversion factors easily, right? Okay, after you do the math, or like it would be 16.2. And even when I'm writing your homeworks, exams, sometimes, I forget to write one of these. So remember, how many numbers you have here. Sometimes if you write things, cluttery, or like sometimes if you don't have enough space, maybe you write something and then forget to take that into account. So remember to have all the numbers that you write, have all of them in your calculator. Okay, and when you do the math, you get the number 3.62 multiplied by 10 to the power of 23, and this would be number of aluminum atoms. Okay. Any questions? And again, check the number. So this is like roughly 16 multiplied by 6 divided by 27. So you can divide this by like 3, right? So it would be 32 multiplied by 9, divided by 9. So roughly, if this was 10, it would be like 3.2. So you have like kind of an idea. So I do this to get the range of the number. I don't want to confuse you. But what I'm saying is that when you put the number in calculator, also check to make sure if that makes sense. Also, remember the number of atoms, molecules, they should be in the order of Avogadro's number. So Avogadro's number is 6.022 multiplied by 10 to the power of 23, and depending on decimal places that you have, this number can become 10 to the power of 24 or 25 or 22. But if you get something, with 10 to the power of minus 5, right? Or if you get something, 10 to the power of, 100. If you get like some numbers that are not in that range, probably you did something wrong. And this is the thing that I always encourage all of you to do. Look at the number, see if that makes sense. If you get the number negative, that doesn't make sense, right? What is like minus 2 students? What does that mean? Doesn't make sense, right? So check your number. Any questions? Good. Okay. Now, what if I give you CO2 and I say what is molar mass of CO2, and I'm going to write this here. What is molar mass of carbon dioxide, CO2? How do you think we should report that number? Can I say that it is 32? Or like say it's 12? Or like 16? How would I do that? Any ideas? Exactly, adding AMUs. So we do basically, again, like for each element, molar mass was equivalent to atomic mass unit, but the unit was different, right? Here's the same thing. Molar mass of CO2 would be its formula mass, but the unit would be gram per mole. So how you solve this, you say molar mass of CO2 equals. How did we calculate atomic formula mass? How did we do that? We said we have 1 carbon, right? Plus 2 oxygens. And then we go to periodic table, and then you see carbon is 12.01, oxygen is 16.00. And then you substitute these numbers here. So 12.01 plus 2 multiplied by 16 is 32, right? So it would be 44.01. And what is the unit of molar mass? Grams per mole, right? If you calculate formula mass, the unit would be atomic mass unit. But if you calculate molar mass, the unit would be gram per mole. So this tells you 1 mole of CO2 has the mass of 44.01 grams. Is that clear? So now I ask you, how many CO2 molecules are in 100 grams of CO2? Can you guys help me to solve this problem? What do I want to find? Molecules, exactly. I say, how many CO2 molecules equal 100 grams of CO2? How can I convert grams to number of molecules? Can I do that directly with just one conversion factor? No, right? So I convert grams to moles, and I convert moles to number of molecules, right? So we just calculated this here. What is the mass of 1 mole of CO2? 44.01 grams, right? And these two cancel out. And what is number of CO2 molecules in 1 mole of CO2? Anyone?
6.022 plus 10.
Exactly. 6.022 multiplied by 10 to the power of 23 molecules. So remember, if you have atoms, molecules, ions, don't get confused. 1 mole of anything is 6.022 multiplied by 10 to the power of 23 of that thing, right? So if you have atom or molecules, this conversion factor is the same. 1 mole of that thing would be 6.022 multiplied by 10 to the power of 23 of that thing. So this would be 100 multiplied by 1 multiplied by 6.022 multiplied by 10 to the power of 23 divided by 44.01, and the units would be number of CO2 molecules. Okay, and you put this number in calculator and find the answer. But if you just want to see the range, this is like 6 almost divided by 44 multiplied by 10 to the power of 25, and then, you know, if it was like 5 divided by 50, it would be like 0.1, like 1 over 10. So your answer should be in the range of 10 to the power of 23. But again, you know, I do these things to have like the range, but you put the number in calculator and get the exact number. Did anyone do that already? Okay, so you just like put the number in calculator and then see what you get. Before you guys go and start your break, I mean, depending on whether or not you have other things, lab or something after this, do the attendance. So you get credit for attending the lecture. So I'm going to post your homework 9 and quiz 3 during the break. So before, you know, and the deadline would be like Wednesday after the break. So I encourage you to go through the course materials and reach out to me. You know, I'll be here answering my emails. So just reach out to me if you have any questions. Okay?